So in our last video, we talked about probability sampling, and what probability sampling is it ensures that there's equal epsom, equal probability of sampling. And so it ensures that we can measure the larger, we can get a sense of our larger population from a smaller population because we're strategically sampling in a way that ensures that we know a certain amount of errors. So we're sort of abiding by statistical methods to make sure that we can generalize about the larger population. But sometimes we want to do research, explore, and get the scope of something, and we don't have the availability of non-probability sampling. And so non-probability sampling is sampling in which the probability that an element will be included in the sample is not known. So epsom, remember that acronym, is equal probability of being sampled, whereas in non-probability sampling, we have no idea what the probability of one observation being sampled is. And therefore, we cannot generalize about the larger population. Our findings are very tentative and they can give us some direction. And if we were to use probability sampling, what types of questions we might want to explore or what themes there are, but it doesn't allow us to generalize. So there are 4 types of non-probability sampling. There's quota, when there's a total sample that has the same distribution and characteristics assumed to exist in the population studied. So the example of Rutgers students being sampled, if we wanted to sample specifically Rutgers students and generalize about the larger population, then we could use quota, but because of the context of Rutgers, we can't generalize about the larger population. There might be convenience sampling. So this might be what a lot of businesses might do if they knock on doors and are trying to figure out if a certain product is interesting to people, right? Or if you're at a football event and there are people who are trying to understand the demographics of people who like football, then you could sample in that way. But you can't generalize about the larger population because there might be differences between people who like football and go to games versus people who like football and just watch it on TV. And then there's purposive sampling. So it's when we can't do probability sampling, but we're trying to get to a similar state of the general population. And snowball is when you interview some individuals and then they find other individuals for you to interview. So I did this in undergraduate. I interviewed people who were formerly incarcerated and I interviewed police officers. And the way I did it is I had a contact for both of those populations and I asked them if they also knew any police officers or people who were formerly incarcerated. And so a big takeaway from sampling in regards to probability sampling, not non-probability sampling, is that the relationship between standard error and sample size. So when we understand standard error is what we can compute based off of the statistical formulas that theoretical statisticians have given us, we can compute what our error is. And so the larger sample size we have, the smaller the error is. And as you see in this graph, it sort of is a very large error for small sample size. And then as you get bigger and bigger, it comes to an asymptote. So that means that the slope gets really, really gradual. So there's never going to be, the line is never going to be at 0 on the standard error side. But the larger our sample sizes, the smaller it becomes. And this is for probability sampling. So for probability sampling, the larger our sample sizes, the smaller the error is. All right, so we're gonna do, this is a little bit of a review about all the sampling we've talked about thus far. And so this first one let's take a second and think about what type of sampling the first one might be. So it's simple random sampling. We see that there's no perceived pattern for why some people are being chosen versus others. There's not a sense of that at all. It's totally random as to who's getting picked. So systematic sampling is the second one. I told you that earlier than I allowed you to guess. Oh well. So this is when we're picking, for this one, it's every third person that they either have a sampling frame, so a list of people, and they pick every third person, or maybe they have people in a room that are the sample and they pick every third person. What do you think the second one is? Let's pause for a second. So we see in this third example on the left bottom that the sample is divided into the lighter blue and the darker blue. And so when we are dividing things, that process is called stratifying. So we're creating like striations. We are making subcategories of our sample. So you see in this environment that if we're talking about making subcategories, we're talking about stratified sampling. So this is where we would divide our population, our sampling frame by category. So in this case, it's light blue and dark blue, or it could be male and female. And so we're trying to get the amount of people that is ensuring that there's proper representation. So if we know the demographics of the larger population, then we could divide our sample into those demographics and choose the same amount of proportions as the larger population. All right, now the last one, the fourth one, let's take a second to think about this one. They are in subgroups of 3, right? So little units, and an entire unit is being chosen. So this is a cluster sample. So remember when I was describing it, I was talking about how they're divided into smaller units, and then the entire unit is what's getting sampled. And so the National Survey of Victimization, which we talked about in the first lecture on sampling, was an example of this, but they did it in multiple stages. So first they had a geographic unit, a PSU, and chose certain of those groups. And then they had a smaller CED unit and chose randomly amongst those different groups. So often researchers will use multi-stage clustering. So it's like doing a first cluster, and then you would do this process in this box again for another group. So instead of people, we might say cities, right? We might have a list of cities that we're trying to get people from. So first we would compose the list, and then we would pick the particular cities. So the cities are groups of people. And then from those cities, we would divide into smaller units, let's say neighborhood, and then we would pick specific neighborhoods and those units. So that's an example of cluster sampling. Alrighty, now we're going to get into this whole slide is non-probability sampling. So let's observe the first type of sampling and sort of scope out what it looks like. So there's one person who's going up to those people that are nearest to them. So the gray figure is the researcher, and then the blue figures are people who are in the sampling frame. So we see that the researcher is going to the entirety of the people around them. There seems to be, as compared to the rest of the sampling strategies, proximity. So proximity means closeness. So there's a closeness to the researcher. So let's think about that, and you try and guess what type of sampling that is. So that type of sampling is convenience sample. And so your book, this is a common term, but your book uses reliance on available subjects as the formal name for this type of sampling. It's also commonly referred to as convenience sampling. And so this is best justified if the researcher wants to study the characteristics of people who are passing the sampling point at some specified time. So you're interested in that specific place and that specific time, and that's why you're doing a reliance on available subjects. Alrighty, let's look at the second one. So in this one, we see that there's not necessarily a proximity, but we're just getting blue subjects. And so let's think about why that might be happening and what type of sampling might be observed in this second one on the top. Alrighty, so this one is voluntary response sampling. So those people, we see the arrows, which we might not have noticed prior, but the arrows are those people are going towards the researcher. So that means that it's a voluntary response. So this might be like if you're doing a survey and you just mass email a group of people, so you don't have control over who responds, it's voluntary. So then that would be an example of a voluntary response sample. And your book doesn't go over this particular sampling strategy, but it is very common, especially for surveys. Alrighty, and in this one, the first one at the bottom on that one, the one that's closest to the scribbler sign. So this one, we see that the researcher is getting a certain amount of people and they're trying to get, so they have 2 of the light blue and they have 3 of the dark blue. And if we look at the sample frame itself, it looks like there's more dark blue in the sample than there is light blue. So what they're doing is trying to get the same demographics of the larger population. So what would we call that? I'll let you think about it for a second. Alrighty, so this is what we call purposive sampling. So what we're doing here is we're ensuring that we're getting an accurate portrayal of the larger population. So in order to do this type of sampling, we have to know what the larger population that we're interested in, what we have to have some sort of knowledge of its elements, the nature of the people in it, and whatnot. So we can't do this if there's the population parameter we're working with, the larger population we're trying to generalize, if we don't have any information about that population. Alrighty, let's look at the last example of sampling. I will squat a little bit. So we see that the researcher is in gray and that they have 2 contacts, and those contacts are referring them and getting the other people in the sampling. And so what type of sampling would this be? I'll give you a second to think about it. Snowball sample. So snowball sampling is like the example I told you before. The researcher has 2 contacts, and in this case, one contact is in the light blue population and the other contact is in the dark blue population. And so the researcher asks, hey, do you know any other people in this group like that you could refer me to? And that person in this instance refers them to 3 other people. And so this is called snowball sampling because if you think about a snowball, at first you start with something small, and then if you keep rolling the snowball, it's going to get bigger and bigger and bigger. And so that's why we call it snowball sampling. Alrighty, so this is basically an overview of all of the types of sampling that we're dealing with. So random sampling is, and I'm just going to go over this and read through this and explain it. So random is that the sample group members are selected in a random manner. So we might use random numbers generated via computer. and it's super highly effective. But when the sampling size is small, it's not. So if I were to randomly choose like between apples and oranges, and I had 3 apples and 5 oranges, but when I randomly sampled, I only got oranges. That's really likely to happen when I'm dealing with 8 observations, right? But if I have a large sampling population, then it's not going to happen. And this gets us back to this. Sorry, it's continuing forever to work through this. This slide here, right? So if I have a small sample size, then there's going to be a large error. Look at that, error is all the way up to 10. But as my sample size increases, then my sampling error decreases. So then we have stratifying. So remember, stratification is we're subcategorizing. That's a good way to remember it. Stratified, striation, subcategorizing. So we have some knowledge of the larger population, and we're gonna subgroup our sample in proportion to the larger population. So this requires some type of knowledge of the larger population that we're working with, and it helps us make precise estimates in cases of homogeneity or heterogeneity within the strata. So it really helps us get to that space of probability sampling, and it also helps us get into a sense of knowing that there's not as much error, right? Alrighty, and then systematic sampling is when we include every third person in our sampling frame. So it's time efficient, it's cost effective, but there's high sampling bias if periodicity exists. And we talked about this in the first lecture. So let's say that we have a bunch of observations of rainfall over years, but we only have 1 observation per season. So if we were to do every 4th thing, we might only get autumn. And so then our understanding of rain is only relative to the season of autumn. So we can't make generalizations about all the other seasons. So if there's some type of pattern that exists within that is temporal and you're using systematic sampling, it might not be the best fit. And then multi-stage. So this is when we are sort of doing random sampling at multiple units. So this allows a lot of flexibility at various levels. For example, especially when we're dealing with like national studies, so say you wanted to get a national population of the US, then you could first divide it into states and then divide it into subcategories within states and randomly choose states and then randomly choose the subcategories. And so it helps if we're trying to get a large swath of a population, and it also helps break down the sampling frame if it's very large into something that's more piecemeal. And it's complex to conduct and limited by cluster and stratified sampling methods. So it can be a little bit difficult to implement because you're doing it you're sort of stratifying at multiple spaces. And so that can cause just like a matter of difficulty in implementing it and actually doing it, right? So these are all of the strategies of sampling. This was sort of a review, and we focused on both non-probability sampling and purposive sampling. So we sort of gave an overview review of the probability sampling, and we also briefly touched on non-probability sampling.